Last week I compared Alibaba's two new models, Qwen 3.6 35B and Qwen 3.6 27B. And I was a little bit disappointed with the results because they were quite shocking. If you have not watched that video yet, you can find the link in the description below. For today, we are going to do another comparison with Google's new model Gemma 4 31B, and we have Qwen 3.6 35B MOE model. Because people are talking about this a lot. Some people prefer 3.6 35B and some people are preferring Gemma 4 31B model. So let's see who's gonna win this match. For this purpose, we have Arena, as we have used the same application last time for the last video as well, and we will be judging these models blindly, which means I do not know which responses are coming up from which model, to keep these things for interesting and fun as well. Before I start the match, let me quickly set the stage. I loaded Q4 version of both the models through Ollama. By Q4, I mean it is a compressed version that fits in the GPU memory we have without losing too much quality. We have got like 32 GB of VRAM, which is just enough to load one model at a time. But we cannot run both the models at the same time, so we run back to back. If you want to know more about this workstation, why I picked it, what's in it, then you can watch my earlier video, and the link you can find in the description below. Another thing I would like to mention is it's a blind match, which means we can only see responses coming as candidate 1 or candidate 2. So we don't know which is which. And talking about the test, I created different types of tests like coding, memory, facts, math, OCR, or browser use. And in every round, I will show you what the test is, and then we can see the responses from the models, and we can judge based on the rules we have specified in the test. And of course, you can play along, pick your winner, and drop it in the comments at the end of the video. So let's start with the first round. Reddit sanity check 9.9 versus 9.11. This is just one test I saw on Reddit, and I found it interesting, so I thought I will just add it to our match here. Sounds easy, right? It is not. Many AI models in the past still got this wrong because they read the dot like a version number, like in software update where 9.11 is higher than 9.9. So let's see the specific rules we have set in this test, like return exactly larger one value, why one short sentence, trap one short sentence explaining the mistake. Do not add hidden reasoning or extra text. Okay, let's look at the response of candidate 1. It took 21.55 seconds. And it returned larger than 9.9. Why 9.9 is equivalent to 9.90, which is greater than 9.11. Trap, treating the decimal portion as a whole number rather than place value. So it seems like the response is right. Looking at the candidate 2, it is a little bit slower, 31.82 seconds, and it is giving the same 9.9 answer as well. Looking at the trap, the teammate confused decimal values with software version numbers where 11 is indeed greater than 9. This is also correct. Now, if I look at the trap, then it is actually making sense. It is giving me the software version trap, which we were talking about earlier as well. Just because it is giving a better trap explanation, I think candidate 2 wins this round. But if we look at the response, like what is larger, then I think both the models have given us the right answer. But because of the explanation, let's pick candidate 2. Moving on to second round. Now, this is a creator coding test. Does the app actually run? A lot of models, like I think most and all of the models are getting better at coding, and we can create applications, we can create websites. So I'm just testing with a small application here. I asked each model to build me a single HTML file. One file, no internet, no install, no extra steps. It must show bars on the screen and sort them 6 different ways. And our requirements are like, you can see on the screen, 6 algorithms: bubble, selection, insertion, randomize button, speed slider, visual bars, show current algorithm, and it must be usable on 1366 pixels wide screen. Output the complete HTML file only, no explanation before or after. So only one HTML file, which if I open, it should give me the app and I should be able to use it. Looking at the responses we have, candidate 1, 109 seconds, and I can see it has created the complete HTML file. And if I preview this file, I can click and see. I can see that we have the bars, we have the buttons, the size, speed, as we mentioned in the test. And if I have to start it, and I can see it is working fine as well. If I pause it, it's paused. And can I increase the speed? Let's resume it. Okay, it's running fast as well, which means sorting. As you can see on the right hand side, it's sorting all the bars. So I think it's working just perfectly fine. If I just change the algorithm, randomize it and start it, okay, this is perfect. This works just fine. Okay, so which means the candidate 1 has done a good job. Let's look at candidate 2, view HTML page. Just I noticed that the scroll bar here, if you can see the size of the scroll bar compared to this, it looks like this output, the HTML file is bigger than this one, even though it took less time, 71 seconds compared to 109. Let's look at the HTML page. Okay, we have a blank canvas type thing. Is it gonna work? Start. Okay, it seems like the bars are moving and sorting as well. It's just a little bit different way of showing it. And can I pause it? No, I think it's not working. The pause button is not working. If I randomize it, no, I can't. Reset, no, it's not working. Speed, okay, I can increase the speed, but I cannot. Okay, so pause button is changed to start now, and this button is working. Reset is not working. Randomize is, I think, working. So seems like the issue is with the pause button only. Quick, let's see heap sort, and I will randomize it, and then I start it. Okay, this one is also working. So it seems like the issue is with the pause button only. Good job, but I would say if I look at the design wise, I think it looks a little bit more polished, the candidate 2 compared to candidate 1, even though this is okay as well, but I feel like the more polished design is here. But what's the point of design if the app is not working, or it's working but not completely? So in that term, I think candidate 1 wins, and we can just pick candidate 1 as the winner of this. Now, I asked if you just to mention here, if we have to ask this to a bigger model like GPT 5.5, I did that, and this is how GPT gave it to me. Like, it's so much more polished, so much more looking better than both the models' output. Of course, because those are small compared to GPT 5.5, and if I just look at it, it works nicely as well. And I can pause it, reset it, just to see like how the big models take the test and give the output compared to the smaller models. Now let's test memory. CodeNeedle, did it read the file? Okay, I gave both models a fake Python file with 5 functions in it. Some of them have very similar names on purpose, like finalize recovery, retry recovery, and finalize queue recovery. Now, the job is simple. Reproduce the first 12 lines inside the function called finalize queue recovery, exactly as written. Do not fix the code, and do not try to summarize it. Do not include line numbers or markdown fences. So these are the rules for this test. And if we'll take a look at the responses, I can see that it is clean. There is no explanation, there is no extra line, just the exact code line. So it gave me in 40 seconds. And if I take a look at candidate 2, then it took a little bit more, 42 seconds, but it also gave me the same thing. So both are correct. The only difference I can notice here is that the candidate 2 started with a function definition line. Here define Q recovery. And then if you see, this part is only same, only this part is different. But we made it clear, reproduce the first 12 non-empty lines inside the functions. Okay, so if we take a look at the requirements, then I think candidate 1 is giving us better response. So candidate 2 a little bit it didn't stick to the rule. Or if I have to say, then in this round we are going to pick candidate 1 as the winner. Okay, let's move on to test number 4. This one is a little bit tricky, but it's a fun one as well, because it is what you actually want from AI when you are writing code. I showed each model 3 database functions. One of them is a real SQL injection. 2 of them are safe. The job is to find the bad one, name the bad line, write a real attack string that would actually dump the user email, say which functions are safe, and give me the fix. Now, if I look, by the way, these are the return exactly vulnerable function, vulnerable line, exploit payload, save functions, fix. Okay, looking at the candidate 1, it gave me the output in 73 seconds. Vulnerable function, get user ID, vulnerable line, I can see where ID, exploit from user, same functions, search user, delete user, fixes, use parameterized queries in get user by ID instead of string content concatenation to prevent SQL injection. Okay, this is good, strong I would say. This attack string would actually pull all emails out in a single shot. This is something like what real attackers do in real life, and it correctly cleared the other 2 functions as well. Looking at the candidate 2 response, it gave us in 40 seconds. Vulnerable function is by ID, same as the candidate 1. Line is also same from user's ID string, user ID. Okay, that is fine. Exploit payload, 1 union select. This is also same. ID, name, email. Okay, here we go. It's a little bit different in this terms. Replace string concatenation. Okay, so it's almost same as candidate 1 as well. Also correct. The attack is a bit gentler, I would say, but it would still work. Both the models gave us the correct output, but I would say the candidate 1's attack payload is a type of the attack that a real attacker would use in real life. So candidate 1 wins this round by a few points, I would say. So let's pick candidate 1. Moving on to test 5, claim sorter, real versus invented inference facts. This one is also an interesting one because it tests the most important AI skill, knowing what is true and what is not. I wrote 6 claims about how AI models works. 4 are real things that exist in the world, and 2 I just invented. I just made things up just to see for this test. Like for example, this one is fake. The Miller saying quantization corrections adds a learned bias. So there's nothing like that. But let's see what the model is going to output. We have few rules like real comma separated claim letters, invented comma separated claim letters. Invented tells for each invented claim 1 sentence explaining the specific tell that it is not real. Okay, looking at the candidate 1, real ACDF, ACDF, the continuous patching gain ratio, CBGR, is a standardized VLM metric. Of course, we made this up. Invented BE, invented tell P, there is no Mueller saying correction in GPQ. Use a second order approximation of the Hessian to minimize quantization error. Continuous patching gain is a fabricated term and it is not standardized metric used in VLLM or general LLM serving dashboards. Gave the output in 25 seconds and it is correct. Looking at candidate 2, it gave us the real as well as the invented. ACDF and BE is invented as well as the tells, and similar to what candidate 1 gave us. The only thing I can see the difference here is 39 seconds compared to 25 seconds. But the output is identical and both are correct. So I would say this is a tie. So I won't pick any of the model in this case. Let's move on to test number 6. Real world finance check payout blocker. Now this one is more like a real world situation where you are working with any of the business or you are doing your expenses or your finances with a local AI model. Now the model needs to know these finances better and needs to know how to work with numbers. And it needs to be accurate. So let's see which model is better than the other. I gave both models 6 invoices and 7 bank payment rows. Some payments are settled, some are still pending. There is one row in there that looks like a payment but is actually a duplicate export. There are also 2 refunds, one settled and one still pending. The job is to figure out if the company can pay the vendor today, and if not, what is still open and how much is missing. So we have already set up the rules here. Due amount, count only settled bank payments, pending bank payments do not count yet. Duplicate blank rows with the same transaction ID count once. A settled refund reduces an overpayment. A pending refund or correction does not count yet. Okay, so these are the rules we have. We have set the invoices. And we are saying that total is 1840, credits 0, status paid. We are showing the status like unpaid as well as paid. Now looking at the payments, these are the payments, and then we can see this T06 INV 105. It's repeating, duplicate export row. Now return exactly, ready to pay, yes, no, net exposure number, open items, invoice ID, customer message. One short sentence, a finance ops lead can say. Okay, looking at the candidate 1, ready to pay, no. Net exposure 2495, open items 102, pending payment 2450, 104, underpaid 45. Customer message, please settle the outstanding balance of 2495 for invoices 02 and 04. And it gave us the output in 35 seconds. And if I look at the candidate 2, it almost took double the time, 65 seconds. And it is giving me ready to pay no, same as candidate 1. It is also giving me the same amount, 2495. And open items are invoices 102 and 104, same. And if I look at the customer message, please note a pending payment of 2450 for INV 102 and a short payment of 45 on 104. Awaiting net exposure is 2495. So both the numbers are correct, even the invoices are correct. Both got the math. Candidate 2 understood the situation a little bit better. So in that way, I would give a little bit points to candidate 2 in those terms, because it's explained better to the, if you look at the customer message, it's explaining a little bit better than the candidate 1. But I think both are giving us the same correct answer. So it's again another tie, I would say. Let's move on to test number 7. Constraint pitch, acrostic, exact word count. Write a 5-line product pitch for a chef knife brand called North Star. Hard constraints, exactly 5 lines. Each line is exactly 12 words. Then first letter of each line read top to bottom must spell NORTH. At least 3 of these nouns must appear somewhere across the pitch. No exclamation marks, no emoji, no M dashes, no headings. Do not reuse the same noun in more than 2 lines. Do not mention competitors or other brands. Okay, so we have it looks like an easy one, but because of the multiple requirements we have, let's see if the model is going to stick to all the requirements or not. Candidate 1 output took 116 seconds, a little bit more, I would say, for a simple prompt like this. Now experience the finest high carbon steel for your home kitchen needs. Our unique design ensures a perfect balance for every single precise cut, razor sharp edge. Quality makes chopping vegetables a fast and easy task. The ergonomic handle provides a comfortable grip during long hours of work. High quality tools come with a lifetime warranty for your total piece. Looks alright to me. Candidate 2, 73 seconds, much efficient. North Star crafts premium steel blades for every serious professional cook with care. Or sharp edges ensures clean cuts through any tough ingredient with ease. Reliable handle design provides comfort during long preparation sessions every single day. Trustworthy warranty covers every purchased against manufacturing defects forever without question today. Hunt each culinary challenge with unmatched precision and graceful handling every meal. Okay, this one is also looking right to me, but if I take a look, I mean the quick look, the only difference I can see right now is like North Star. I do not see the brand name in this output of candidate 1. Even though we are saying that a 5-line product pitch, I mean, if you're talking about a product pitch, then you should include the brand name in the pitch at least. So in that term, if I have to judge this round based on the output of these two responses from 2 models, candidate 2 is included in brand name, which gives a little bit edge over candidate 1. So in this case, I would say I will pick this one. Moving on to test number 8. Agent recovery, fix the failed form state. Now, a lot of people are using local AI models for automation, be it agentic or be it browser automation. And if you're doing browser automation, you are going to deal with a number of forms. Now, this is what we are going to do here. The prompt is you are reviewing a browser agent after a failed vendor onboarding form submit. The agent must now produce the safest correction patch before trying submit again. So one agent filled the form and made a mistake, it failed. Now our AI model, I would say, has to fix it and give it back to the AI. Source of truth from the task brief. Legal name, these are the submissions like field names and what are the values. Current browser form state after the failed submit. We can see delivery window is empty, terms are unchecked, must be checked. Everything else I think looks fine. It looks okay. And IFSC is also empty. Visible validation error, GSTIN must match the 15 characters. Okay, so GSTIN is okay, S5Z5. Okay, this is wrong. Confirm account number does not, IFSC is required, delivery required, window is required. Okay. Return only JSON array. Each item must have exactly field action value. Include only fields that need to change. Do not include email or phone because those are already correct. Okay, so let's look at the responses. Candidate 1 gave in 34 seconds and I can see field legal name, action update, value is Neela travel, field GSTIN update set 5, this is correct. Account number confirm update to 21, this is correct as well. IFSC TFC 1234. So if I look at the IFSC, yes, 21 and set 5. Okay, this looks values are looking right. Delivery window, weekday morning, terms check true. Okay, this looks correct to me. Candidate 2 gave us 43 seconds, 10 seconds, 9 seconds, I would say, more than candidate 1. Field legal name, action, field value. Okay, this action type is fill, and here we have the action type as update. It is picking the same data as well. Z521, action fill value. Action fill value is 1234 filled. Action fill value weekday morning. And true. Okay, so the only difference I see is the type of fill. It's update and its action is fill, but both are correct. Both got the right data. It seems like this is another tie. So we can move on to test number 9. Viewer checkable OCR, what can you prove? Okay, this one is another real test. I would say we have a receipt and we are sending a receipt to both the models, and we are checking the vision capabilities, the OCR capabilities of the model. So the prompt is, look at the test receipt. Viewer will also see the image on screen. Return exactly visible total, string or null, 3 visible items, names you can actually see, unsure 1 sentence, naming that you cannot confidently read. Do not invent missing values, do not output JSON. Looking at candidate 1, 27 seconds, much faster. Visible total is 191, Merchants Real Seafood Co. 3 visible items, parts for fish, main scale. Unsure, all text on the receipt is clear, legible. So it says that it's not unsure of anything, all text on the receipt is clear, legible. So if I have to show you the receipt that we are sending, let me show you. This is like just picked one receipt from the internet, and I can see the Real Seafood Co. is the restaurant name, and we have a few items like Riesling, CSJ, Blue Points, parts for fish, main scallops, Campi pasta. Total is 191.86. Okay, this looks right. Seafood Co. and 191.86. The only thing it says the unsure is it's not unsure of anything. Everything is clearly legible. Looking at candidate 2, it is taking more than double the time of candidate 1, 67.49 seconds. And if we see the output, again 191.86, Real Seafood Co. 3 visible items, CGT, Riesling, ADZ, parts, Campi pasta, and unsure. I cannot confidently read the subtotal value because the digit appears to be 3 instead of an 8. Okay, so it is saying that it cannot read the subtotal, but compared to 1, which says that it can see everything. If I look at this, then the subtotal it is 181, that's for sure. But if we look at the receipt, then it also looks like 131. It's not visible, like completely visible. So in that time, I think model 2 has given us the more like grounded truth, I would say. And if I have to go into the thinking, because it looks like 1900 characters compared to 16,000 characters. So why is it like taking so much time, and what it is doing in the thinking? Visible total, merchant name, 3 visible items, just comparing everything. I will pick 3 colors, 3 clear ones. Unsure, logo text is bit. So it's just checking what is not clear of. Subtotal and text are readable. The food line at the bottom says this. It's doing the calculation, the sum. The subtotal listed as 131, but it is getting 181. So it's just trying to just check like the subtotal is making sense or not by summing the total of all the items, and which is good. Let's see if candidate 1 is doing something like that. Visible total, merchant, swordfish, the product names, item total is here, visible total is 191, and it is not picking subtotal anywhere, like it's not considering subtotal anywhere. That is why it missed it. Okay, so we can see clearly the model behavior is one model went through the script receipt in a fast manner, I would say. So it skipped a few things. It just maybe just picked the bigger items, not the smaller ones. Maybe the total, the items it can see here. Not sure why it skipped the subtotal and didn't even mention in the thinking. And if I look at candidate 2, it got stuck like why it was getting a different subtotal when it is doing the math compared to what it can see on the script. Is it possible that subtotal is just subtotal food item? So it is doing the subtotal calculation a lot more because I believe it is trying to see like if it's completely unsure of subtotal or not. So as you can see, it did the calculation a number of times and then finally it concluded that subtotal it cannot be sure of. So that is the reason why it took 60,000 characters of thinking and more time of 67 seconds. So in that terms, I think Model 2 has done a better job at understanding what is the prompt and what is the situation and what is wrong and what is right. So I think Model 2 wins at this test clearly. Moving on to test number 10. Browser use, as we have done this before as well when we were testing Qwen 3.6 35B and Qwen 3.6 27B. That time as well, both the models failed this. And let's see if Gemma is any different or Qwen 3.6 can do a better job this time. So we have a real world browser use exercise. We just have to fill this form with these values. That's the thing only. If I see candidate 1 timeout after 5 minutes, so there's nothing. If I looked at candidate 2, 161 seconds, that's good, and it's success. Steps used 2 by 24, we can see a lot more details, but contact name is Ria Sharma, and it says John Doe. Email Ria Serena, example.com, John Doe. It almost looks like it just filled a form that doesn't even exist. So which is completely weird, which of course we have seen this before as well. In my last video, if you see, we did the same test and both the models, like one model timed out and another model just created a form and filled it, and which didn't exist at all as well. So it seems like the same pattern, same behavior. Model is maybe this candidate 2 is again Qwen 3.6. I don't know, but all I can say, this is not right. This is complete hallucination of the model. So it's a big tie, I would say, and none of the models won this one. Okay, so all our tests are over. We can look for the scoreboard. So looking at the score, we can see Gemma and Qwen 3.6 both are at 3. So it seems like a tie. But if I look at where they have won, Gemma is kind of expert or I would say better in coding, because all the 3 tests it won are related to coding test, like the coding test, code needle, security audit. So the focus seems like it's doing a better job at code rather than the general purpose, the OCR one. Let's say where is the OCR one? Yes, if I look at the OCR one, Qwen 3.6 35B won, and if I look at like the acrostic exact word count, then again Qwen 3.6 won, and the sanity check where which model gave us the better explanation, Qwen 3.6 again won. So more general use case, I think Qwen 3.6 has an edge. But if you're doing something related to coding, I think Java 431B is better. But both in case of browser use, they have failed. They could not fill a simple form. So that's our results. Let me know if you have done your reading as well. Let me know in the comments which model you think performed better than the other. For our test, I think it's a tie.